So I previously discussed a lot of different areas of reverse engineering, primarily focusing around the idea of interpreting different instructions and understanding program flow. And at this point, you would probably have enough of an understanding to start to look at some real examples of reverse engineering. So I'm going to start by talking a bit about a basic program where we're trying to figure out something like a hidden password inside of a binary itself. Then we'll expand this out further and we'll start talking about different types of exploit type situations like things like return-oriented programming, stack overflows, heap overflows, these types of ideas. This will be a good starting point for you to understand some of the basics of how we can actually work with the binary and understand how we can interpret the instructions of it in an actual more live type of program. So I've got a binary here that I'm using. It's one from a capture the flag type exercise, and we'll primarily be using these capture the flag type applications because they're really good ones for learning the basics of reverse engineering. You'll be able to find this binary in the description of this video along with any other binaries that we end up using. So one of the first things that I'm going to do here is I'm just going to try running this program just to see what the behavior of it actually is. You'll see that it prompts us for some sort of input. We enter in some sort of input. It gives us some sort of rejection message. And the idea is that we want to figure out the input that's going to actually let us through and give us a valid, successful message. One of the first things that we often do in this sort of situation is we take a look at the structure of the file itself just to understand exactly how this file is structured. We see that it's a 64-bit ELF-based binary. That might be helpful in this decompilation. It certainly will be in future videos when we take a look at more complex types of reverse engineering. So understanding these pieces, we're going to go ahead and get this loaded up in Ghidra. I've already got this set up. If you don't have this already, just create a new project in Ghidra, go ahead and click and drag the binary in, and you'll get to the same place as me. Now, understanding the basics of how these actual applications are flowing, we've sort of discussed a lot of these different ideas so far, but let's try to understand a bit more about how this application is working. When I take a look at the main function, which I can find typically automatically once Ghidra runs, if you don't see it, just go to the Functions tab on the side here and select Main. You'll see basically what ends up happening is it starts off by declaring two variables. We have this ivar1 and then this void pointer pvvar2, right? pvvar2, what we do first is we allocate some memory for it, and then eventually we're going to use that to scan for an input. So this looks to be where it's taking the user input. To validate this, we could take a look at this puts instruction. The puts instruction will print text onto the screen, right? If I double click on this, it will show me what text is being printed. And you'll see that this is the prompt that we get when we first boot up the application. So that's the prompt that we get when we first boot up, and then it's going to take an input from us using this scanf function. What eventually ends up happening here is it runs this input through this validate function. If the output from that is 0, it puts this message here. This looks to be the rejection message that we get with an invalid input. And then otherwise it prints right this way, which looks to be our success message. So from this, we can really conclude that our goal is to get ivar1 to equal something other than 0. And the way that we do that is through this validate function. So let's go to this validate function and try to understand it in a bit more detail. You'll see here this validate function is a little more complex. And to help with the complexity, I've actually renamed some of the variables to make them a bit more clear. If you want to do this in your own Ghidra project, you can do it just by right-clicking on the variable and saying rename variable. So you'll see here that I've labeled our output so that we can see that clearly in our application. I've also done things like labeling the index for the loop itself, and maybe we've got a few others in here. So let's talk through exactly what this function is doing. It looks a bit complicated, but once we sort of break down the main ideas, you'll see that it's really not so bad. We have a bunch of different variable declarations, so we'll kind of ignore those for now. We see this big block of declarations, and when I'm looking at this block of declarations, I see these hex values, and what I'm thinking immediately is that these hex values look like text, and the reason why I see that they look like text is because they are around the value of 60, and 60 upward in hex is typically representing ASCII values, right? So you can see that when you see like 66, 6C, 61, it usually is character-based data. That's pretty typical for this kind of range of hex values. So I'm sort of thinking that in my head, and then once I see this string length, I'm kind of thinking, okay, maybe this is actually just like a set of strings. It turns out that this is the string length of our input, right? So it's starting with the input length itself, and then it looks like it's doing a loop inside, doing something with this input itself. When we take a look further at what's happening, it's comparing our input at an index I, and checking to see if it equals this local 48 at the same index I. And if they ever don't equal each other, this variable gets set to 0 and it jumps over to this label. This label returns that variable. So we could see pretty clearly here that if our input doesn't match this local 48 array at index I, we get a return of 0. That's the unsuccessful situation, right? Now, that being the case, we want to figure out what happens when we are able to return something other than 0, right? And it looks like basically that happens if we make it to the end of this string and we haven't found something that doesn't match. So basically it's just comparing those two strings with each other, making sure that every single character matches. So our intuition is correct here that this looks to be a string. So how do we get this into text that we can understand? The answer is that we can just take these values and plug them into a hex decoder. So I just do 66, 6C, 61, so on and so forth. I've already done that, so you don't have to watch me type it all out one by one. And you can see here that when I put these values into the hex to actual text conversion, we get this value here. This is the flag for capture the flag. So in this case, if I input this into my application, so I go ahead and run it, I can paste this value in. And you'll see that I get right this way, which is the success message. So with that, we've successfully reverse engineered this application. We've found the secret password, and we were able to get access to the application itself. This is sort of complementing that idea of a binary reversing that we talked about earlier on. One way that we can do this is we can patch the binary, right? We can actually change the functionality, but that's not always going to be possible for us to do. In some cases, we need to understand the flow of the logic and be able to find the correct value to input in order to get to a certain location in the application program itself. So this is an example of doing that process. This is a really basic sort of reverse engineering task that we may often need to do. So in the next few videos, we're going to introduce some more complex tasks, mainly around the idea of buffer overflows, which are a very interesting area in the field of security engineering. If you're doing any sort of security work, buffer overflows are really great to know about. So we'll try to dive into those in as much detail as possible, and I'll show you a bunch of different examples for doing so. So that's everything for this video. Thanks so much for watching. I'll see you in the next one.